Christina Koch grabbed the window frame so hard her knuckles went white. Not from fear, not from turbulence, from what she was looking at. She didn't say anything for almost 11 seconds. 11 seconds of complete radio silence from a trained NASA astronaut who had spent over 300 days in space and had never, not once, gone quiet like that during a mission. Then she said 4 words: "That is not right." And the room in Houston went cold. What she saw in that moment, what all 4 of them saw during those 7 hours, is something that has been sitting in classified debrief transcripts, buried under processing backlogs, and quietly avoided in every official press release NASA has put out since they landed. I'm going to tell you exactly what it was, but not yet. Because to understand why it matters, you need to understand what they were actually supposed to see. What every astronaut before them was told they would see, what 53 years of official science said was up there, and why that version of the story turns out to be almost completely wrong. Stay with me until the end, because the last 2 minutes of this video will change the way you think about every moon mission that came before this one. Here is what NASA told the public about the moon for half a century. Dead, gray, understood. 3 billion years of nothing, geologically simple, photographed from every angle, mapped with lasers, analyzed with spectrometers. A museum piece floating in space 240,000 miles away that we had basically figured out. The Apollo astronauts came back and said the same thing in different words. Quiet, monotone, covered in dust. Every official debrief, every press conference, every training document pointed to the same conclusion. We know what's up there. We've known for decades. Now, here is something that barely made the news. On April 6, 2026, 4 astronauts flew to within 4,000 miles of the lunar surface aboard the Orion spacecraft. Not to land, just to look, to observe, to do what no human had done in over 50 years. Fly that close and actually pay attention. Their names were Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. They had spent 2 years training specifically for this observation window. A planetary scientist named David Kring had personally drilled them on mineral colors, crater geometry, shadow behavior, and surface texture. They were not passengers. They were field geologists operating at 4,000 miles altitude. And almost immediately, they started seeing things that didn't match. Not dramatically, not in a way that screams conspiracy, in a way that's actually scarier. In a way that says our instruments were right, and they still weren't telling us the whole truth. Victor Glover could not stop staring at the Terminator. Not the movie. The Terminator is the line between lunar day and lunar night. The boundary where sunlight hits the surface at such a low angle that every ridge, every crater rim, every rock casts a shadow 10 to 20 times its own height. Glover had seen photographs of this, hundreds of them. He'd studied them. He'd been tested on them. None of it prepared him for what he actually saw. He described valleys that looked like black holes, pockets of terrain so deeply shadowed they appeared to be physically missing from the surface. Kelsey Young, the mission's lunar science lead, listened to his description from Houston and said later that this was exactly the kind of observation that human eyes contribute that no camera ever could. Here is why. A camera captures light, a fixed amount, at a fixed wavelength within the limits of its sensor. A trained human brain connected to eyes that have spent months learning what specific minerals look like under specific lighting does something completely different. It compares. It notices when a color shifts where it shouldn't. It registers that the floor of a basin is a subtly different hue than the rim. It catches gradients that a sensor records as background noise and throws away. Jeremy Hansen, the Canadian astronaut on the crew, said the thing that shocked him most was the 3-dimensionality. On screens, on paper, in every simulation, the moon looks like what it technically is, a sphere covered in craters. In person, through the window of a spacecraft moving through actual lunar space, the elevation changes hit completely differently. The elevation differences near the moon's south pole are greater than the height of Mount Everest. Photographs had been showing them this data for years. Standing at the window and seeing it was something else entirely. And the colors. Nobody expected the colors. The crew reported shades of brown and green on the near side, distinct color variations across crater walls and lava plains that orbital photographs had suggested but never confirmed. These variations correspond directly to mineral composition, iron deposits, titanium concentrations, subtle shifts in reflectivity that look nearly identical in photographs but separate into distinct hues when a trained human eye is looking directly at them. They were doing geological field work from 4,000 miles up, and they were finding things that 50 years of robotic data collection had completely missed. Halfway through the flyby, the moon swallowed the sun. From the crew's perspective, the sun slipped behind the lunar disk and vanished. The corona, the sun's outermost atmosphere, bloomed around the edge of the moon in a ring of white light that no human being had ever seen from this angle. From Earth, a total solar eclipse lasts maybe 2 minutes, 3 if you're lucky. From 4,000 miles behind the moon, totality lasted 54 minutes. They put on eclipse glasses during the partial phases, becoming the first human beings to ever use eclipse viewers at the moon. When totality began, they took them off and looked directly at the scene. Wiseman called it absolutely spectacular, the kind of word that sounds like an understatement when you hear the full description. Stars appeared, Venus, Mars, Saturn, Mercury, all visible simultaneously beside the corona, which was now the only source of direct light in their sky. Earth glowed in the distance, its reflected light falling softly onto the darkened lunar surface below them. Glover compared the solar streamers radiating from the corona to the spotlight on top of the Luxor Hotel in Las Vegas. Then he took it back. He said, "This is what that wants to be when it grows up." And then, in the darkness, the surface started flashing. 6 times. Brief points of white to bluish-white light appearing on the darkened lunar surface, each one lasting less than a millisecond, as fast, Wiseman said, as a camera shutter opening and closing. In the science evaluation room at Johnson Space Center, scientists started screaming. Not metaphorically, audible screams of shock, of disbelief, of pure scientific delight. They were meteoroid impacts, small rocks, not dust but smaller than a boulder, slamming into the surface at tens of thousands of miles per hour and vaporizing instantly on contact. On Earth, objects that size never reach the ground. The atmosphere destroys them first. On the moon, there is no atmosphere. Every single particle that approaches the surface arrives at full speed. The crew had been told they might see 1 or 2 impacts if they were extraordinarily lucky. They saw 6. The backup astronaut for the mission told reporters afterward that 4 or 5 sightings would have been outstanding. 6 was something nobody had a framework for. But here's where it stops being a beautiful science story and starts being something with very real consequences. NASA is planning to build a permanent base on the lunar surface. That is not speculation. That is the stated goal of the Artemis program. And a rock the size of a marble traveling at 40,000 miles per hour carries enough kinetic energy to puncture a habitat wall. On Earth, you don't worry about this because the atmosphere is your shield. On the moon, you have nothing. No air, no protection, just open sky and everything in the solar system that wants to fall through it. A professor of geological sciences at Brown University said after this mission that the impact frequency observed by the Artemis II crew means the daily flux of incoming meteoroids needs to be understood in far more detail before any permanent structure is built on the surface. He wasn't being cautious. He was saying, we thought we knew this number. We didn't. And if we build a base based on the number we thought we knew, people could die. That's what 6 flashes of light actually mean. But there is one more thing. One thing the crew observed that sits in a different category entirely from topography and mineral gradients and impact frequencies. One thing that has been staring at us from the lunar surface since the 1600s, and that to this day, not a single scientist on Earth can explain. You can see it from your backyard. With a decent telescope on a clear night, you can point at the moon and find it yourself. It sits on the near side, in a dark volcanic plain called Oceanus Procellarum, a bright swirling pattern spread across roughly 60 miles of otherwise dark basalt. It looks like someone reached down and stirred the surface with their finger, a curl of light material winding through dark terrain with no edge, no crater, no physical boundary. It was spotted by astronomers in the 1600s and initially classified as a crater. Then, orbital photography revealed the truth. It casts no shadow. It has no topography whatsoever. It is completely flat. The swirl pattern is not a physical feature. It is purely a difference in how much light the surface reflects, painted across terrain that is otherwise physically identical in every measurable way to everything surrounding it. Its name is Reiner Gamma, and it should not exist. Here is what sits beneath it. A pocket of magnetized rock in the lunar crust that generates a localized magnetic field strong enough to form a miniature magnetosphere stretching 360 miles across the surface. The moon has no global magnetic field. It lost that billions of years ago when its core cooled and its interior dynamo shut down. But scattered across the crust, frozen into rock that solidified when the moon was still young and still generating its own field, there are these remnants, fossil magnetic fields locked into stone. Reiner Gamma sits directly above one of the strongest of them. The leading theory is that this magnetic pocket deflects the solar wind, the constant stream of charged particles flowing out from the sun, and that this deflection is what created the swirl pattern you can see from Earth. The solar wind slowly darkens exposed lunar soil over millions of years through a process called space weathering. Where the magnetic field shields the surface, the soil stays bright. Where the field has gaps, particles concentrate and darken the soil even faster. The result is a pattern of bright and dark that traces the exact shape of the magnetic field, like a tan line on skin that was partly covered by a strange piece of fabric for 100 million years. Except, and this is the part that nobody can resolve, it doesn't fully work. The magnetic anomaly doesn't align neatly with the geological structures around it, unlike similar features elsewhere on the moon, which sit on the exact opposite side of the globe from major impact craters, suggesting the impact itself somehow magnetized the crust on the other side. Reiner Gamma has no corresponding impact origin that anyone has been able to identify. One hypothesis is a comet strike. Another suggests a buried, uniformly magnetized elliptical disk beneath the surface from an extremely oblique impact that grazed the moon at a shallow angle. A third theory proposes that fine dust particles launched by micrometeorite impacts were sorted by the local magnetic field into the bright swirl pattern over millions of years. None of them have been confirmed. A future mission called Lunar Vertex, led by Johns Hopkins Applied Physics Laboratory, plans to land a rover directly on Reiner Gamma and drive across it, measuring the magnetic field and soil properties at ground level. That mission has not flown yet. So right now, in 2026, Reiner Gamma remains exactly what it has been since 1600. A pattern on the surface of our nearest neighbor in space that 4 centuries of observation, orbital photography, spectral analysis, and scientific modeling cannot explain. Now here is what the Artemis II crew actually brought back that matters. Not the photographs, not even the impact data. The thing they brought back is a corrected model. For 53 years, every piece of data we collected about the moon went through instruments, sensors that captured exactly what they were programmed to capture, algorithms that processed exactly what they were calibrated to process, models built on those outputs that described exactly what the models were designed to describe. And the model said, quiet, gray, understood. 4 people flew there with their own eyes and in 7 hours found things that decades of robotic observation had been quietly understating. Colors more complex than sensors suggested. Topography more dramatic than photographs conveyed. Impact rates higher than baseline estimates predicted. And a feature visible to amateur astronomers for 4 centuries that remains, in the most precise scientific language available, genuinely unexplained. This is not a conspiracy. The Apollo astronauts did not lie to protect a secret. They reported what their instruments told them. The instruments were right. They just weren't telling us everything. And now, as NASA prepares to land humans on the surface for the first time since 1972, everything the Artemis II crew saw, every color shift, every shadow that revealed a cliff no photograph had shown, every flash of light that meant another impact on an unprotected surface becomes survival information. The moon is 240,000 miles away. We have been staring at it longer than recorded history. And after all of that, after every mission and every dataset and every model, 4 people flew there, looked carefully, and discovered that everything we thought we knew was just the rough draft. The final version is still being written, and the next crew that goes down to the surface is going to be living in it.